right, good afternoon, everyone in Algebra 2 and Trig. It's Mr. Kong again, here to talk to you about multiplying and dividing radical expressions. Hopefully you didn't find yesterday's lesson too challenging with simplifying radicals such as square roots, cube roots, fourth roots, etc., etc. Today we're going to look at multiplying and dividing radical expressions. Now, the number one rule that we have to look at when we're multiplying and dividing radical expressions is what we must look at when we're multiplying and dividing radicals is we must make sure that the index of the two radicals is the same, right? If the indices are the same, then we are allowed to just multiply or divide your radicands. Okay, even if the radicands are different. Later on, we'll look at if the radicands are the same, but the indices are different. But for today's lesson, we're just multiplying and dividing radicals by making sure that the radicands are the same first. Okay? After that, it's going to be the same lesson as you did yesterday. Okay? Now, listen to me, guys. Here's the tip of the day. It's usually easier to multiply or divide your radicands before you simplify the radical. So take a look at this. In this first example I've got the cube root of 4x squared y to the fourth is e to the fifth times the cube root of 54 x to the fourth y to the seventh is e to the sixth. Since these indices are the same, I know I'm allowed to just multiply the radicands and make one big radical. When I do that, I get the cube root of, well, let's see here, 4 times 54 is 216. X, well, remember, when we multiply x's, we add their exponents, so x to the sixth, y to the 11th, and z to the 11th, okay? Now from here, it's just yesterday's assignment. You guys try and simplify this, this radical on your own. Okay, well, let's see if you get your answer right. Now, to do this, I've already done the factor tree for 216 here, all right? Now, since I'm doing the cube root, I'm looking for groups of 3. Well, let's see. I've got 3 3's here. I also have got 3 2's. So the 3's come outside the radical, the 2 comes outside the radical, and that gives me 6. Now with the x's, remember we just divide the exponents when you're working with the variables. 6 divided by 3 is 2, so x squared would come out. 11 divided by 3 is 3, so y cubed comes out. But remember that I would have a remainder of 2 y's inside the radical, so that becomes a y squared. And then z's, I've got 11 z's divided by 3 again is 3 z's. Oops, sorry. I've got 3 z's, and I've got a remainder of 2 z's on the inside. Okay? Now, don't forget, this index right here that we had has to stay in the problem. Don't forget to write that. So your final answer should be that. Hopefully, when you pause the screencast and you did your problem, you got that answer. Let's do this one. Now this one is a division. In this one, instead of multiplying the radicands, let's divide them. Okay? Well, let's see here. The indices match, so I know I'm allowed to do this problem. Okay? 96 divided by 3 is, I believe, 32. X cubed over x divided by x is x squared. Y to the fifth over y is y to the fourth. And z to the 10th over z to the third is z to the 7th. Now again, notice, I've just simplified the fraction without working with the radical itself. The radical is still there, but by taking these two radicands and dividing them, I create the single radical. The single radicand, right? And now you simplify, okay? Again, pause the screencast and you got, did you get 2yz times the fourth root of 2x squared y cubed? I hope so. Well, that's just simply multiplying and dividing. Again, so really you're just one step away from yesterday's lesson. Multiply your radicands or divide your radicands to create a single radical. And then just simplify the radical like you were doing yesterday. All right, the next idea. Rationalizing denominators. Now, I know that we've done this in the past, so it's not totally new material, but obviously there must be something new that we're about to learn. Suppose I have this problem right here, the square root of 24 over the square root of 15 over x. Ladies and gentlemen, when you rationalize the denominator, remember that you are not allowed to have a fraction with the radical in the denominator. You have to move that radical from the denominator up to the numerator by using the conjugate. And you have to get rid of, you must get rid of the radical from the bottom. Okay, now let's take a look at this. The first thing I say to myself is, well, wait a minute. We just talked about this. Could I simplify the radical expressions? Can I simplify the radicands? Yeah, don't 24 and 15, don't they both have a 3 inside of them? So couldn't you create that as just the square root of, well, 24 divided by 3 is 8, over 15 divided by 3 is 5. So you get this, okay? And, well, wait a minute. Doesn't the square root of 8 simplify to just 2 square root of 2 over the square root of 5x, right? Now, again, for square roots, if I want to get rid of this square root right here, don't you have to have pairs of things? Well, right now I've got 1 5 in here, so if I want to get rid of that 5, I have to multiply by the square root of 5. I have a single x in here, so if I want to get rid of the x, wouldn't I have to multiply by a single x? Right? But what you do to the bottom, you have to do to the top, so I have to multiply by the square root of 5x here. Well, by doing so, in the numerator, I get 2 times the square root of 10x over, well, whenever you multiply a radical times itself, don't I have a pair of 5s and a pair of x's now? So wouldn't that just become 5x, liberating my 5 and the x from the radical? And I've simplified this and made sure that there's no radical on the bottom. This next one's kind of a doozy, right? This is really where we get into heavier, deeper water here. I'm going the cube root of 16 over the cube root of 9. Now, even though the indices match, 16 and 9, these two fractions, these two radicands, they don't simplify. So now, I have to work with the radicals, okay? So with the cube root of 16, do I have 3 of something inside of a 16? Well, if you think about 16, 16 is 2 to the 4th, right? So if I have 16 equals 2 to the 4th, would you read, I can take out 3 of the 2's, leaving 1 of the 2's on the inside of the radical. See how I got that? Think about that. And on the cube root of 9, well, see, what does 9 break down into? Well, 9 only breaks down into 3 times 3, right? Oh, wait a minute, that's not enough 3's to take out. I have to have a group of 3 3's, and I only have 2 3's. Well, wait a minute. Couldn't I just multiply then by the cube root of 3? By multiplying by the cube root of 3, wouldn't I have those 3 3's that I need? But if you do that to the bottom, you got to do that to the top. Now, once we do that, we get 2 times the cube root of 6 over, because I now have 3 3's inside the cube root, those 3's get to come out as a single 3. And voila, I've done this problem and rationalized the denominator. Okay? Let's do one more problem. Okay? This one, again, is a little bit more challenging. The first thing I say to myself is, can I simplify the fraction itself? All right? Yeah, 15 and 20 have something in common, faux show. Let's see, I can divide both 15 and 20 by 5, so I get 3 over 4, right? And I would get x to the 4th over x is x cubed. And I would get y to the 7th over the y to the 12th is y to the 5th on the bottom, right? Now again, because of that, I've got the 2 different radicals that I have here. And I can't simplify really that much any further, right? Oh, wait a minute, I'm over line who lies. In the y to the 5th, I can take out one group of 3's, and in the x cubed on the top, I can take out a group of x's. So when you get x times the cube root of 3 over y times the cube root of 4y squared, right? Now, again, this radical on the bottom, I have to get rid of him. I have to get rid of that radical on the bottom. So let's see, what would I need? I need to have groups of 3, right? Well, right now, I've got a 4 on the bottom. Well, wait, couldn't I break him up? If I did the factor tree, wouldn't that be 2 2's? And y squared is y squared. How many more 2's would I need to get to liberate the 2's from the cube root? Well, wouldn't I need a single 2? Now I've got 1, 2, 3 2's. The 2's get to come out. With y squared, I've already got 2 y's. I would need 1 more y, and that would give me 3 y's that could come out. Alrighty, so if I do that to the bottom, then I've got to do the same thing to the top. So I multiply the top by the cube root of 2y. And then lastly, I get x times, since these indices match, and they always will, I get x times the cube root of 6y over, well, let's see, the y comes out, or this y is already on the outside, and then the 2's come out, so times 2 times another y. So ultimately my answer is x times the cube root of 6y over 2y squared. And that's my answer. Guys, that's how we work with multiplying and dividing radicals and rationalizing radical expressions. Hope you understand this. Talk to you tomorrow.